Okay guys, here we go. This is the practice test. We are going to start in from the beginning. We'll see how this goes. So our first question, probability is never negative. That's true. The very smallest that a probability can be is 0. If something is impossible, it's 0. So that means that this number 3 is false. A counterexample of this would be the probability of drawing a 14 from a standard deck of cards. Decks of cards only go up to 10, so there are no 14s. The probability is 0. Maybe you can hear in the background, my family is having a movie night. We'll see if we can figure out which movie it is. So then probability is never greater than 1. That's true. If something is guaranteed, the probability is 1. If something is guaranteed, the probability is 1, or we could say 100%. I'm kind of writing off the screen there. Okay, number 4. If you add the probabilities for every outcome in the sample space, the result is never 1. That is false. In fact, if we were to change this word never and say always, then that would be true. So, for example, if we were going to flip a coin, the sample space for flipping a coin is heads and tails. The probability of heads is 1/2. The probability of tails is 1/2. And so if we add all the probabilities of all the sample space, we get 1. Let's go ahead and finish this page. Get it lined up with my super fancy camera holder. Okay. So in the game of rock, paper, scissors, 2 people play, and it's equally likely that you will win, lose, or tie. The probability of losing twice in a row. So 1 round of rock, paper, scissors has no effect on the next round. So 2 different rounds of playing rock, paper, scissors are independent, which means I can take the probability of losing and again the probability of losing. Losing the second time is, I guess I should be consistent here, is unaffected by whether or not the first time was. It stays the same. And so we want losing and losing. Lose and lose. Or we could even use the word both. If it's an and or a both problem, we multiply. So the probability of losing is 1 out of 3. We multiply that, and we get 1 out of 9. Now the probability of winning at least once in 2 tries, I'm going to kind of take a different approach to this. This time I'm going to write out the whole sample space, I think. So if I play twice, I could win and win, I could win and tie, or I could win and lose. I could tie and win, I could tie and tie, I could tie and lose, or I could lose and win, lose and tie, or lose and lose. There's 9 outcomes possible in the sample space of going twice. So winning at least once, I'm not prepared here. Winning at least once. So at least means it could be once, it could be twice. So here's winning at least once. And we've got 1, 2, 3, 4, 5 of those out of 9 total. We could leave it as a fraction. We could take 5 divided by 9 and get a decimal or percentage. Then finally, the probability of having, can I get it out of the shadow? Sorry, this is terrible quality. Having the same outcome twice in a row. Well, that could be a win-win, a tail-tail, or a lose-lose. So 3 out of 9. If you wanted to, you could reduce that, but you don't have to, because it didn't ask for it. Let's wrap up this video. More to come in the next.